Okay, page triangles. This the vocabulary. Guys, if it was my notes, I wouldn't bother with what I typed in there.
Teachers and students, we are now ready for theater.
If it was my notes, I would just write this. Solving a right triangle means finding all three angles. But then also finding all three what, guys? That's it. Finding all three sides. And this gets into Ellie's question earlier on the warm-up. What if you know everything but the angles? Is there a way to find that? Yes. We're going to do that in just a little bit. Now keep in mind your notes, there's so much like built in there for you, right? It's like fill in the blanks. I don't love that. So use your margins like crazy. Tyler, you have a question?
Yeah, I actually
Here we go. I always look for the easiest thing first. So we don't know the angles like Ellie brought up, but we do know two of the sides. What theorem can we use to find the missing side? Let's do it. Not too bad, right? Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. So 4 squared plus 8 squared is going to equal your c squared. Okay, guys, you have this. What's 4 squared? What's 8 squared? Okay, add them together. Do you know what that is? Perfect. 80 equals c squared. How do you get rid of that squared? Square root it. Can you estimate it real quick? It has to be below. There's a perfect square right above it. Has to be below 81. Perfect square, that's 9. So I bet it's real close to 9. Grab your calculators, honestly. Everybody type in this in. Is it 8.9? Perfect, because it's right there, right? So now we know all three sides. I'm just going to put it in my triangle. C is 8.9. Okay, scavenger hunt. Back to Ellie's question. We've been using sine, cosine, tangent on your calculators, right? Look on your calculators. Find, for example, the tangent button. What's right above it, written in light blue? It looks like this. That's called the inverse tangent. Ellie, that's what we're using. We're going backwards. We're finding the angle. We don't know the angles. So for this next part, let me erase this real quick for room. You just pick one of the sides and you choose a trig function to use, and then use your calculator for the rest. Right here, I always like to use what's given if they're whole numbers. It just seems to come out nice. Now I know for sure I didn't mess it up. So let's start with the tangent of A. So start at A. What's the trig for tangent? So what would it be? What over what? Perfect. Opposite over adjacent, so 8 over 4. Because what is 8 divided by 4? Okay, so the tangent of A equals 2. Now here's where students start using this button at the wrong times. You only use the inverse of tangent when you're looking for an angle. When is the only time you use it? Looking for what? That's it. That is the only time you use the inverse. So how you type it in your calculators, try this first. You've got to pull up the inverse of the tangent. You know how to get there? You use the second button. And then I think a parenthesis pops up, does it? So then just put in 2. It'll crank out the angle for you. And let's just round it to the nearest whole number. So what nearest whole number angle would it be? Perfect. So now we know that angle A is about 63 degrees. I'm going to put it in the triangle. Okay, yes, for B, you can use an inverse trig function again. However, what do all angles add up to equal in a triangle? Let's just use that tricky, okay? 180 rule. So 90 plus 63, subtract it from 180, or just do it in your head. I just think to myself, 90 minus 63 is 187, is that right? All right. Angle B, 27 degrees. Do you have all three angles? Do you have all three sides? Did we solve this right triangle?
Yes.
Check. So new thing for today is that inverse button. But you only use the inverse when you're looking for what? Only for angles. You just gotta keep telling yourself that. Okay, let's do another one. This one, same thing, just use your margins like crazy. Okay, I look at this triangle and my eyeballs red flag one thing. I always look for the easiest stuff first. Maybe that's lazy, maybe that's smart. Depends who you're talking to. I'd say angle P, I would find that first. Because what do all three angles have to add up to equal? 180. So let's do that first. I just think, all right, 180 minus 90 is 90. So what plus 53 3 is 90. Is it 37? Okay. So right there we've got all our angles. Angle P is 37 degrees. Okay, to find the sides, it's back to what we were doing. We know all the angles, so don't use the inverse. You're just going to use straight up trig functions. Doesn't matter what you start with. I like to be nice to myself, so we know the hypotenuse, so I would use sine or cosine because they both use the hypotenuse. Let's start with angle 37. Let's do the sine. What's the trick for sine? So. What does so stand for? Opposite of hypotenuse. Perfect. So what's opposite of 37 degrees? P. What's the hypotenuse? Okay, Christian, you writing this down? Definitely want you to write this down. Because what do we have to times by on both sides? 30. Then grab your calculators and type it in. So 30 times the sine of 37 will give us P. Okay, can I get a hand in there? What did you get? Okay, then what'd you get? 18.1. Let me see how many of you got 18.1. Whew, okay. Same thing, but let's solve for Q. I'm just going to use the cosine. Are you okay with that? Cosine of Q, guys, what's the trick for cosine? What does cos stand for? Perfect. What's adjacent of 37? Perfect. What's hypotenuse? Perfect. What are we timing by on both sides? 30. So it's the same thing, only with the cosine, right? So in your calculators, type in 30 times the cosine of 37. That'll give us side Q. Little guy Q. All right. I have a question for you, even though you probably already have it in your calculators. Do you remember when we talked about across from the smallest angle has to be what kind of side? Smallest side. Across from the biggest angle has to be the biggest side, so this should be in the middle, right? Between 18.1 and 30. Somebody have it? What is it? What'd you get, Abigail? 24? How many of you got that? 24? Yes, thank you for saying with me. Okay, let's do another one. Okay, number 1. Default. Which theorem are you probably going to use on this one? Let's use Pythagorean theorem. Go for it. I want to see everybody writing this down. So leg squared plus leg squared is hypotenuse squared. 80 squared plus 8 squared. 89 squared. Guys, are you using your calculator to your advantage? Do you know there's a square button on it? Yeah. Okay. So I would subtract 80 squared from both sides. And then my calculator, I just do 89 squared minus 80 squared. And I think, will you check me, is that 1521? Okay. Square root that to get the final side. So A is going to be the square root of 1521. And I think it's a whole number, is it? What is it? Yes. All right. Worth a Jolly Rancher. Okay, this is called something. When the triangle has a whole number here, here, and here, the triangle is called something. For a Jolly Rancher. Do you remember? It's been a long time. Do you remember? Yes, I'll let you have it. Pythagorean triple. Remember that? We went over that and over that, but it's been a long time. Don't let me forget you. Pythagorean triple. Okay, we have A. Now we've got to find angle A and angle B. Which button are you going to use on your calculator if you're looking for angles? The inverse. Now, does it matter where you start? The only thing that's off limits is this C. Do you know why that's off limits? Why we can't do sine, cosine? It's the right angle, and so, like for example, if you're doing opposite over hypotenuse, possible, right? They're the same thing. Okay. So let's do A. How about just, I don't know, the sine of A? So sine of A, opposite over hypotenuse, is going to be 39 over 89. Now we're looking for an angle. So all you do is you pull up the inverse, make sure you're practicing the inverse. It pops up a parenthesis. Guys, how are you going to do 39 over 89? What does this line stand for? So I would just type it in like that. Do 39 divided by 89. And then again, let's just be nice for ourselves. Round to the nearest whole number angle. What did you get? 26? Okay. Okay, and yourself. Once you know angle A, use the 180 rule to solve for angle B. So just think to yourself, what plus 26 will equal 90? I think so. Garrison said 64. Anybody agree with that? Okay. 64 for this one. Okay, number 2. Will you try this on your own? I'm going to walk you through this one, right? We've only learned one new thing. Try to get ahead of me on this while I talk to McCall here. Okay. McCall, we're solving right triangles. You need to know all 3 sides of all 3 angles. That's how you solve a right triangle. So right here, this one's 90, this one's 31. We can solve this because they all have to add up to 180. So I just think to myself, 90 minus 31 is 59. Will you check that though? Okay, so we've got angle D. But now I have to solve for E and F. This is exactly what we've been doing. So just choose a trig function. How about, what if we do tangent of 31? So tangent of 31 will be opposite over adjacent. So E over 8. So times by 8 on both sides, right? Okay, have you typed it in? What did you get? 4.8. Okay. And then just the same thing, only for F. This one, I think it's going to be a backwards problem no matter what. So let's start at 31 and do, how about cosine? Instead of 31, it's going to be 8 over F. So this is one where you need to times by F on both sides. So then we'll have F times the cosine of 31 equals 8. So divide by the cosine of 31 on both sides. So just grab your calculator and type in 8 divided by the cosine of 31. Hopefully it's bigger than me. What'd you get? So I'm going to put 9.3? Okay. Kaden, comment question?
Wouldn't it be easier to use the tangent of 31 than use Pythagorean theorem?
Sure. Yeah. Kaden said, can you do the tangent of 31 and then Pythagorean theorem? Absolutely. Absolutely. You know what, McCall? We didn't show you the new thing. The new thing was on this one, not that one. That's old stuff. The new thing is if you're ever looking for an angle, look at your calculator. You want to use the inverse of the sign. It's on your calculator. It's right above the sign button. You see how it says sign -1 right above it? But it's only when you're looking for an angle. We'll help you if it comes up again. Okay, what's next on your notes? Is it the hockey problem? Flip that page. Yes. All right. This is interesting. Okay, we've got this hockey problem. Let me walk you through it. Right here is the hockey player. Da, da, da. Hockey player shoots it at what angle of elevation? Okay, so he shoots it at a 7-degree angle, right? That's the angle of elevation. How tall is the goal? How many think he'll make it if he shoots it at an angle of 7 degrees? How many think he's not going to make it? No? Okay, there's a way to figure it out using trig functions. That's what we've been talking about. So the whole point, he's 35 feet away. We know this is 7 degrees. We want to see if he can get it within 4 feet. So let's put our x here, and then we'll compare it to the 4 feet. So think where x is, think where the 7 degrees is, think where the 35 is. Which trig function is that? I think it is tangent. Do you agree? Because it would be opposite over adjacent. So the tangent of 7 will be opposite of 7 is x. Adjacent is 35. Alright guys, what do you times by on both sides then? 35. Grab your calculators. Hopefully we did this right. So type in 35 times the tangent of 7. What'd you get? Did you say 4.3? So what does that tell us? Did he make it? He barely went over it. He went over the top. Does that make sense? He only had that 4-foot window to fit, and he missed it. Went over it. Okay, next hockey problem. Same sort of idea. Only this one is saying, all right, what kind of angle does he have to shoot at if he wants to make it? So this one we're looking for x. So Allie, McCall, Callie, watch this one because this is our new thing for today. Otherwise it's the same trig function. So this one, we're looking for an angle. We haven't had to find an angle yet in this section. They've been given to us. And we're looking for an angle. Everybody who's here, which button do we use? The inverse button. If you look at your calculators right above the sign, there's like a sign -1. Above the cosine, cosine -1, that's what we're using. So same thing as before. Let's use the tangent. So the tangent of the unknown x is going to be opposite over adjacent, 4 over 27. Okay, girls, you okay with that setup? That's what we've been doing. But now, what we have to do is grab the inverse on your calculator. It comes up like this. Tangent to the -1. And then it pops up a parenthesis. And then you type in 4 27s, which is just a division problem. So literally type in 4 divided by 27. Should be a little angle for a hockey player. Okay, what'd you get? 8 point, what is it? 8.4? How many got the same as Abigail? Yeah? Perfect.